early universe was radiation dominated. Most of the energy was made up of photons and neutrinos. By 6 million years after the Big Bang, the radiation had redshifted down to almost all infrared. After the initial radiation from the original Big Bang cooled, for about the first 100 million years, or maybe a little more, the universe was completely dark until the first stars formed. At about 100 million years after the Big Bang, the densest parts of the universe start to halt and collapse back in on themselves to form stars. The first stars were massive, 1 million times brighter than the sun, probably 20 times hotter than the sun. Today, stars are born in great numbers from the same cloud, but the first stars were born one at a time because the universe was much hotter. Stars born from hotter gas are much more massive because the hotter gas resists gravitational collapse. Some stars have been burning for 13 billion years. They will eventually become red giants, then collapse. The sun has been burning for billions of years, but if it were about 3 times bigger, it would have probably only burned for about 230 million years. Some giant stars can last as little as tens of thousands of years. Then they become red giants, then supernova. Their supernovas can last as little as a few weeks. After a giant star's supernova, they collapse and become neutron stars or black holes. After about 6 million years, the universe was about 450 degrees Fahrenheit, about the same as a household oven. By 10 million years, it was equal to water's boiling point. By 15 million years, it was the temperature of the human body. By 17 million years, it was the same temperature as water's freezing point. The point at which the universe went from hot to cold was the point at which its temperature equaled its mass. The particles' kinetic energy equaled their mass. The average density of the universe is 5.8 hydrogen masses for every cubic meter. That's equal to about a grain of sand within the volume of a fist. The universe is about 73% dark energy and about 23% dark matter. It's about 4% atomic matter and about 0.005% light and about 0.0034% neutrinos. On average, every cubic meter of the universe contains about 400 million photons, about 1 billion photons for every proton or electron. There are about 1 proton and 1 electron per 4 cubic meters in the universe. You can visualize 4 cubic meters as the size of a large car. The universe contains about 10 to the 53rd kilograms of mass energy. The universe is homogeneous on scales larger than about 200 million light years. Roughness in the universe peaks at about 200 million light years. It's smoother on both larger and smaller scales.